Okay, greetings dear friends. So today right now we're going to continue somehow programming of microcontrollers, but for this case it's not going to be Arduino, it's going to be pic16F84A. So we're going to use a software that's MPLAB IDE. Sure, you need to download it online or get it maybe from a friend. So let's open our MPLAB. I had to open mine before. So here's the way it looks like. So today right now I'm just going to do the basic programming in MPLAB and how to start a project. So I'm just going to make a LED shine through a Proteus. Since we don't have the microcontroller, we use Proteus microcontrollers. So let's get to project. To start a new project, yeah, we get to project wizard. From there we hit next. Here right now they say device. Depending on the microcontroller you're going to use, you make sure you choose the right one. As you can see, there are so many of them. So the one we're dealing with right now, we're going to say pic16F84A, and then we'll say next. Okay, why is still loading? You need to wait somehow, so it takes time. Okay, once that's open right now, you make sure at this point here we have so many components. You make sure it's a tool suite. You tap there, okay there. From there right now is okay. You say next. So next right now we say browse. Either you create a new folder or you can use an existing folder. But let me just show you guys how to create a new folder, so that when you are doing yours, you can just create at once. So we come at this point, create new folder. Here it is. Okay, create new folder. Here it is right now. You put the name. Let's say shine LED somehow. Okay, you say open. Okay, shine LED right now. Let's see somehow inside that one. It's a LED. Yeah, LED blink. Though it's not blinking a LED, but let's just put this for now. Depending on name you'll be saving with. Since that is okay right now, you say next. So yeah, you're not going to add or remove anything. You say next, and that's finished for now. So you notice right now that we have this, where we have source files, header files, object files. So from there right now, you come to your new file where they're going to give you a sheet where to write your program. So our program somehow is a little bit long, so I'm just going to explain it. Let's copy it from here. I copied it already, I typed it already. Okay, so we say copy. Okay, I'm just going to explain the code since somehow it's long. I don't want the video to be too long. We say paste. Okay, right now here we have our code. This list P here right now, P somehow is for the PIC microcontroller. The P that stands for the PIC equals to. So since right now we choose 16F84, we set A right, so we need to add there A. So include right now. Let's say hash include, but in this case we don't say hash. So here also you make sure you put A. So here right now we are somehow initializing some terms, like assigning them, just like in C programming where you say int x equals to a certain tree. So right now these are registers location 03H. You cannot be using them in our code because it will be somehow complex to understand. So we assign them to certain words in which you can easily understand. And assigning them, we use a keyword which is equal. That stands for equal. That's the status here is equals to 03H. That's where all of them here right now are. So we are going to modify this code somehow was for. Okay, we have initialized the three of these guys. So as you know already, in PIC programming you need to initialize your ports. Like you need to set your ports. Which port is this? So here right now we are setting from bank 0 to bank 1. That's B set F. So we are moving from our bank 0 to bank 1. That's setting pin number 5 being high. That's the meaning of this statement here. So second next statement right now, we have move LW. That's move literal value to the working register. So what do we want to obtain? An output at the let. So 00 stands for output. So if all is 00, we know that all our pins at the bank 1 stands there for the output. From there right now, we have defined all our outputs at the bank 1 being 00, meaning their output. So but right now, all of this is inside the working register. You need somehow to place it in the file register. That's the 85H. So instead of the 85H, you just say trace A. If you assign it already to trace A. From there right now, since you have set your port, you have set which one is output, and at the trace A, you come back to your bank 0. That's a B, C, F. From here right now, this other guy here was for something else. Okay, we have this. We're going to see those cases somewhere else about labels. So we have set our port. So the next thing right now is to make our LED shine. As you can see, we have 02. This 02 is in hexadecimal. Putting it in binary, you are going to have something 0010. So it is the second pin in our port A, which is going to send an output. So that's the meaning of this statement here. So right now it is at the working register. You need to make sure it is at the file register. Then the file register name where at port A. So just make sure you put here port A. Okay, port A. So after this, our code is done to be run. So right now you just say N. That's where our code N somehow. So we need to save. Say Control S. Okay, Control S right now. You need to go to the folder we created. Make sure you retain the name. Do I know mine again? Here it is, shine LED. So we're going to open it. Somehow save. But let blink. Okay, right now it is saved already. I'll save it, so you make sure you retain the name. So you come right now at the level of source files. You say add files. Here it is, add files. Yeah, we have added the file. Right now we have added the file we just saved. That's it, the let blink.asm. So from there right now, we build our code at this level. So to build it right now, you say absolute. Okay, right now it is loading. It is still loading our code. It is building. So these areas you are seeing here, that's where they will represent you your errors. So you can still run your code and there's an error. This way you're gonna check where exactly you have the error. So our building was successful. We get back right now to our code. Make sure you double save. From there right now, let's go out. We come back right now to our shine LED. Here it is at the desktop. Let's say we open it. Okay, so after opening it, here is the let blink.mcp. So it is actually there. So from there right now, you can double tap here. Okay, we can't actually open it because this one is open. So this was okay, dear friends, sorry the programming part has some misunderstanding. So I'm taking it over right now for the secretary part. Let's get right now to our pic. As here we're going to have pic16F, that's the 84A precisely. Okay, here it is. We're going to say okay. So apart from that, we need a LED. We're going to use a blue LED. Okay, blue LED right now. Here it is. We say okay. Okay, we need also a ground, so we're going to get a ground after. Let's place our pic. And let's place our blue LED. And then let's place our ground at the level of the LED. And connect it to the LED. Okay, right now in our code, right, we set 02H, that actually is to pin 2 of port A. So we have pin 0 here, that it stands for the first pin of port A, and here is the second pin of port A. So we connect it to our LED so I get the code. Okay, right now it is connected. So to look right now the code to our microcontroller, we double tap on it, we get to program file, we tap on it, and from program file right now, remember we place it at desktop. From desktop right now we place it at a certain point, shine LED, that's a shine LED there. You open, okay, shine LED right now we have the LED blink and the LED blink dot this. So we open this, you see right now it has been placed in our microcontroller. From there you say okay. Okay, right now our microcontroller has its own code. Let's run right now our Proteus to see the reaction. Okay, our Proteus is running. You see right now that's what the code actually to do, send output to the second pin of port A. So it was a success. Make sure you subscribe to the channel so that you follow the next videos and do more complicated projects using the PIC microcontrollers. As for the Arduino, we'll be continuing to Arduino, so